Okay, today we are going to discuss the unit 2.2 selecting suitable apparatus for experiments, and this is the learning outcomes. At the end of the lesson, you should be able to select suitable apparatus for collecting a sample of gas. Let's review our previous lessons about the solubility. Actually, there are two types of solubility, known as the soluble or insoluble. Solubility means the ability of a substance to dissolve in the water. For example, solubles such as sodium chloride. The sodium chloride is the solid state at room temperature and pressure. We can see from this picture that the sodium chloride dissolve in the water. Here is the sodium chloride, the solid particle NaCl, and this is the water. You can see that the NaCl can't dissolve in the water. At the end of the reactions, we can see that the solid particle of the sodium chloride like disappear in the water. And then insolubles, what is meant by the insolubles? For example, like HgCls. The HgCls cannot dissolve in the water. That is the solid of the HgCls. Even we stir the solutions, the mixture of the HgCl and the water, but the solid of HgCl cannot dissolve in the water. And then let's looking at the density. You have learned the density from grade 7 at junior high school. Why does ice float in the water? We can see from this picture that the position of the ice cube is higher than the water. Why? Because the density of the ice cube, the ice cube less dense than the water. Ice cube less dense water. It's why the ice float in the water. Methods for collecting gases. The method of collecting gases will depends on the solubility of the gas in the water, and then the density of the gas compared to air. The first method collecting gas known as the downward displacement of water. The downward displacement of water, we can use this method for the gas that are insoluble or slightly soluble in the water. For example, like carbon dioxide, CO2 gas, H2 gas, or oxygen gas, O2 gas. We can use the displacement of water because carbon dioxide gas, hydrogen gas, and oxygen gas are insoluble or slightly soluble in the water. There is the set of apparatus to do the experiments using displacement of water. This is the glass jar. We can use the measuring cylinder, or test tube. This is the gas particles. The bubbles is the gas particles, and we also use the delivery tube. Okay, let's watch the video about the downward.
How can we collect gases that we can neither see nor touch? If we could collect these gases, we could then identify them. Two gases may seem identical, but how can we collect them? And how can we test them to be sure? The objective of this lab is to collect an unknown gas, and later you can identify it. The materials that you'll need for this lab are 3 small test tubes, a larger test tube filled with water, supported by a universal support stand, a 1-hole rubber stopper, surgical tubing, and a glass elbow, a trough to collect the gas, already filled with water, and half an Alka-Seltzer tablet. Assemble the apparatus as seen here. Place the small test tubes in the water so they're completely filled with water. Make sure that there are no air bubbles. Place half an Alka-Seltzer tablet in the test tube. Place the rubber stopper in place securely and submerge the glass elbow under the water. If the reaction ends prematurely, you can add half an Alka-Seltzer tablet to continue the reaction in order to collect the rest of the gas.
Yeah, this is how you have to use the downward displacement of water for insoluble or slightly soluble gas. Yeah, this is the bubble of gas. Yeah, because the bubble of gas insoluble or slightly soluble, yeah, it's why we can use the displacement of water. And then, yeah, the next method, yeah, known as the downward delivery of gas, yeah, is for collecting gases that are soluble in water and denser than the air. Yeah, for example, like chlorine gas, yes, Cl gas, or hydrogen chloride, HCl gas. Yeah, there's the set of experiments using glass jar. We also can use the test tube or measuring cylinder. Let's looking at about the density of the gas. Yeah, this is the gas particle. The gas particle here, and it is the particle of the air. Particle of air. Yeah, let's look at that the gas particle is denser than the air. Yeah, we can see that gas particles, yeah, at the bottoms, and then the particle of air, yeah, at the top. It means the gas particles, yeah, is denser than the air particles. Yeah, it's why we can use the downward delivery of gas, yeah, for the gas particle that denser than the air, yeah, like chlorines or hydrogen chloride gas.
To collect gases using downward delivery, first pour 2 cm³ of hydrochloric acid into the conical flask. Next, add 2 spatulas of marble chips. Place a delivery tube over the conical flask and pass the carbon dioxide produced into the lime water. A white precipitate is formed in the lime water.
Yeah, and then the last method for collecting gas, known as the upward delivery of gas. For collecting gases that are soluble in water and less than air. Both downward or upward delivery gas for the gas that are soluble. And then special for upward delivery gas, for the gas that less than the air. For example, like ammonia. Here is the set of experiment, set of apparatus. Here is the gas in, and this is the gas jar, measuring cylinder. Or test tube. Let's compare this the gas particle. Let's compare the density of gas particle and air particle. We can conclude that the gas particles less than the air particle. It's why we can use the upward delivery of gas. The gas particle less dense the air particle, because the position of the gas particles in the top and the position of the air particles at the bottom. Let's watch the video about the upward delivery of gas.
For the collection of gas using upward delivery, first pour 2 cm cube of hydrochloric acid into the conical flask. Followed by 2 magnesium strips. Place a delivery tube over the conical flask. Then place a test tube over the delivery tube and collect the hydrogen gas produced for 20 seconds. Next, place a burning splint at the mouth of the test tube. The burning splint will extinguish with a pop sound.
This is the upward delivery of gas. In the neck, for collecting gases, to collect and measure the volume of gas, we can't use gas syringe. We have learned about it, the gas syringe. To collect and calculate the volume of gas. And then here is the table that shows solubility and density of common gases. There are 3 methods for collecting gas. The first method known as the displacement of water. And then the second method known as the by using the delivery tube. It can be downward delivery or upward delivery. When we use the displacement of the water, we can use the displacement of the water if the solubility of the gas is not soluble or insoluble or slightly soluble. When we use the delivery tube, we can use the delivery tube downward or upward delivery if the solubility of the gas are soluble. Soluble. If soluble, we can use the delivery tube. But when we can use the downward delivery, we can use the downward delivery if the density of the air, if the gas particle denser than the air, we can use the downward delivery. When we can use the upward delivery if the gas particle less dense the air, such as ammonia. And when we can use the displacement of water, if the solubility of the gas insoluble or slightly soluble, such as hydrogens, oxygens, oxygens, hydrogens, or carbon dioxide. Like chlorine gas, yeah, we can use the downward delivery, Cl2 gas. And then drying gas, yeah, pass the moist gas, yeah, through a drying agent. Yeah, what are the drying agents? Yeah, the drying agents such as concentrated sulfuric acids, H2SO4, quicklime, yeah, calcium oxide, CaO, or fused calcium chloride, CaCl2. Yeah, that's the drying with concentrated sulfuric acids. Here is the concentrated sulfuric acids, yeah, that are used to dry most gases, yeah, except ammonia. And it is the moist gas in, yeah, the gas will pass through the concentrated sulfuric acids and then out here, the dry gas out here. And please take a note that the position of the delivery tube, yeah, the tube introducing to the gas, yeah, immersed in the exits, yeah, while the exiting tube here is not. And then drying with quicklime, yeah, calcium oxide, yeah, this is the moist gas in, and then will pass through the calcium oxide, yeah, the quicklime, also known as the quicklime, yeah, used for drying ammonia, and the dry gas out. Last, drying of fused calcium chloride, yeah, this is the moist gas will pass through the calcium chloride. The diffuse calcium chloride is used for drying most gases, yeah, and it's the dry gas out. Here is the concept map. Yeah, we can't collect the gas, yeah, using, yeah, suitable apparatus. Yeah, there are two methods, yeah, for collecting gas. The first method as displacement of water, and then the second method known as the displacement of air. Yeah, when we can use the displacement of the water, yeah, if the solubility of the gas, yeah, the gas particles are insoluble or slightly soluble. Yeah, when we can use displacement of the water, yeah, if the gas particles so soluble, soluble in the water, yeah, it can be upward delivery or downward delivery. Yeah, it will be related to the density, yeah, with the air particle. Okay, let's discuss, yeah, from the questions number 1. Yeah, gas P can be collected using the apparatus sound, yeah, based on the diagram only. Yeah, what can you infer about gas P? Here is the gas jar, yeah, measuring cylinder, or test tube. Let's look at, yeah, this is the set of apparatus, yeah, gas jar, the derivative, and this is the gas P. Yeah, what is correct? Yeah, it is denser than the air, it is insoluble in water. It less than the air, it is soluble in water. Yeah, this method known as the displacement of air. Displacement of air. Let's look at the this is the gas particle. Yeah, at the bottom of the tube, and this is the air particle top of the tube. Yeah, we can conclude that the gas particles, yeah, denser than the air. Yeah, because the gas particles, yeah, at the bottoms, and then the air particles at the top. Denser than the air. Yeah, what method is used to collect carbon dioxide. But it's the correct method. Yeah. Let's look at the solubility of carbon dioxide. Yeah, carbon dioxide, yeah, slightly soluble. Because slightly soluble, yeah, we can use the displacement of water. What is the displacement of water? Yeah, is the correct answer. This is the displacement of air. Yeah, one method is used to collect ammonia. It's ammonia. Yeah, let's looking at the solubility and density compared to the air. Yeah, ammonia soluble. Yeah, it means we cannot use the displacement of water. Yeah, we can use downward delivery or upward delivery. But looking at about the density of the gas ammonia. Yeah, the ammonia gas less dense than the air. Yeah, which one represent the gas particle? This is the gas particle. If downward delivery, yeah, we can see that the gas particle denser, denser than the air. The gas denser than air. Let's look at the upward delivery. That is the gas particle. This is the air particle. Yeah, we can see that the gas particle, yeah, less dense. The gas less than the air. So the correct answer is ammonia cannot be collected by the displacement of water. Yeah, why? Ammonia is insoluble in water. Ammonia is soluble in water. Ammonia is denser than the air. Ammonia is less than the air. Yeah, we can use displacement of the water if the gas insoluble or slightly soluble. But yeah, we cannot use the displacement of water yet to collect ammonia. It's only for the insoluble or slightly soluble. So it means the ammonia is soluble. Next, the oxygen cannot be collected by upward delivery. Why? Yeah, this is the set of upward delivery. And let's compare. Here is the gas particle. This is the air particle. Yeah, we can conclude that the gas particle less dense. Gas less dense than air. Particles. But we cannot use the oxygen. Yeah, it means that the oxygen particles, yeah, denser than the air. Yeah, we cannot use upward delivery because upward delivery only for the gas particle that less dense than the air. So it means oxygen particles, yeah, is denser than in the air. That's why we cannot use upward delivery to collect oxygen gas.